Everybody's seen the Beatles album that has the Yellow Brick Road album, I think it was, and they were walking across the crosswalk.
Yeah, Abbey Road.
Yeah, Abbey Road. Thank you.
You're mixing up Elton John and the Beatles, and that's inexcusable, Dale, but we'll let it slide. Hey everybody, welcome to the Pulse podcast from Wavetronix, where we talk about everything traffic, everything transportation. Let me tell you about our guest today. He has more than 30 years of experience in the transportation industry, including 18 years at Wavetronix. Throughout his career, he has collaborated with industry leaders, contributed to large-scale projects around the globe. This guy is a globe trotter, all aimed at making intersections safer, smarter, and more efficient. Dale Bartlett is currently a regional manager at Wavetronix, so that means you're a big shot, Dale.
Well, I don't know, Todd. It's kind of define a big shot.
I don't know. We'll look that up, and we'll get back to it on another episode of the podcast. What we're talking about today is traffic detection, and it's something a lot of people, like before I got into the traffic industry, I don't really know what traffic detection was. I just thought, okay, I've got to pull up to a certain point in front of the stoplight so that it'll change.
I don't even know if people know that.
Yeah, a lot of people don't.
And that is kind of the magic about the traffic industry, is so much happens that people just don't know. They just assume and it just happens for them. And when it doesn't, however, is when they notice it. And I think that's been the iteration of the traffic detection industry, is helping people not have to notice as much anymore.
Yeah, it's magic, it's technology, it's a lot of science. It's crazy what goes into making a light change from red to green. And it blows my mind. So where do we want to start with traffic detection? When was it needed in society?
Well, it took a while. I mean, there for a while, a police officer would just be in the middle of an intersection. He would just direct them with his hands. And then, they decided, hey, we can do this with some really cool lights. I don't know if it was Christmas time or what. So we ended up with red and green and then eventually yellow, because yellow came much later in the industry. But the idea really is how do you efficiently flow traffic as it increased? Because when it first started, when there were just a few vehicles on the road, there wasn't that much need. It was just like the horse and buggy. Everybody's kind of going slow. Everybody could kind of just maneuver around. It wasn't until the speeds went up and congestion started happening that people required it.
And it makes sense that from what I've studied is that this started in London. Like the first traffic lights were in London. Yeah. They were gas. And that wasn't particularly safe, right?
Not necessarily, unless you wanted to be right next to it all the time and get a little bit of warmth off of it in a cold London day or night. But that's not what you really want, is to have something volatile in the middle of an intersection that could blow if the conditions were just right.
Yeah, and that's what happened in London. One of them blew up on a traffic officer. Yeah. So you got to do away with those, but they were, like you were saying, it was physical detection. It was the police officer noticing horse and buggy or cars and then having to change something. How did that evolve?
The evolve really came when more technology allowed for mechanical changing of those signals. So where the officer could step back, and then they would put some timing mechanisms in there. They were just gears and wheels, basically, that as soon as it went to a certain point, it would change from red to green at that point, and eventually then green, yellow to red in the industry. But they would then look at it and say, okay, I'm going to take this pin out and put it over here, and now I've got a different timing pattern. They were typically all four directions off of a single head, and so they had to figure out how to light those differently. But the incandescent light bulb, the electrical, having electricity, all of that had to evolve before we were able to do what we do now.
Yeah, and the first electric traffic light was actually just up the road from our office here in Salt Lake City. A traffic cop invented that, right?
Yeah. Because I think he didn't really want to stand out there, especially in Utah winters, directing traffic and making sure everything was working properly. So he figured out a way to utilize the mechanics of it. But the mechanics only get you so far, depending on the level of traffic that's there. As soon as that traffic level goes up, and what we found really, what they were dealing with in Utah was unique, because back east and in many other places, their roadways were pretty small. Utah developed huge roadways from the beginning, and so the amount of traffic that was allowed on a road increased significantly, and they had a bigger problem. That's probably why the innovation started here.
So what happened? How did it evolve from just a traffic officer saying, okay, there's a car there, we need to change it? What different devices or mechanisms were used to let the traffic signal know that there's a car there?
So at one point, you're going to have an officer or somebody else over on the corner of an intersection where they could actually get away from the traffic as much, and basically have a wired system where they could wirely maneuver that. Or then we go into the mechanicals, where then the mechanics just change it whenever it felt like it needed to on a routine basis.
Just a timing
mechanism. Yeah. And in reality, a lot of major cities today still just time their lights.
Yeah.
There is no detection that is there. And they time it for the pedestrians and the traffic in order to have all modes of transportation hopefully run smoothly.
So what is the downside to just timing an intersection?
If as that traffic pattern changes, you need to go out and you need to rechange that cycle. So it may be, and also during certain times of the day, you need different cycles during the day. So now you need multiple timing cycles throughout a day. You can't have, as it used to be, just one gear mechanism that changed the lights the same 24 hours a day. And a lot of times they would do what they call, and some cities I think still do, small towns, they just flash them in yellow at night. There's no detection. You just basically treat it like a yield, and everybody just kind of goes because there's a couple cars at night. So there's still a lot of things we do today that were done at the original onset of a traffic signal.
And they mostly work, but if there's some sort of big event or something, then it's just going to rely on that timing pattern, and other roadways are not going to get served the way they should.
Correct. And so then what you have to start looking is, how do we then find ways to manipulate or change that signal based on the flow of the traffic? For instance, if you have a main line of traffic, you're not, and you have your side streets that have 2 or 3 cars an hour, you want most of that green always on that main road. But you want to know when somebody comes up, because if you have that on a really long cycle because of that, then those people could be sitting there for a long time period. I mean, 4 or 5 minutes in a car sitting there, and it seems like an eternity. Even a minute seems like an eternity. And so you have to know when they are. So they started playing around with pressure pads. Well, you take a place that has lots of freeze and thaw and snow and rain and all kinds of other things. You can imagine the problems that created. But it was an iteration. It wasn't until about, I'm thinking even in the 50s, 60s, that we could start utilizing solid state relays and such, in that we could put an inductive loop at an intersection. And that became, and to a lot of people today even, is a standard of how to detect a vehicle. And I just don't know if too many people know how it all works. But from there, it went from inductive loops to, when I came into the industry, it was all loops, and cameras were just starting to come into, to then coming into radar is the latest iteration. And there are more and more technologies that will be developed over time.
So let's talk about inductive loops. And we see those at intersections.
Sometimes,
yeah. And they're basically just dug into the pavement, correct?
Correct. There's a very small saw cut that they will cut a 6 foot by 6 foot square or a 6 foot circle into the pavement. Now, sometimes they'll actually put those in a PVC piping and actually bury it before the pavement goes over the top. That's why you say sometimes you won't see them. And those last longer. The others tend to have more problems over time just because of wear and such. But when you've made that saw cut, you will then wrap typically 4 turns of wire, run that back to your traffic controller that is connected to an amplifier. And what that does is it actually sends out a voltage to that, which creates an inductive field around there. So when the ferrous metal of the car comes up, it then says, oh, there's something different about the field that in which takes place. And so you have thresholds, and it says, oh, I'm going to say that's a car here. And therefore, I have to tell the controller that runs the lights, there's somebody here waiting. Now, find the safe place to transition so that person can move over. And it's this very simplistic way of doing things. There's a lot of complication as to even the type of loop that you would use depending on the type of vehicles and the type of loop that you want to implement.
Yeah, I mean, it's a tried and true technology, right? And a lot of agencies love it, but there are some downsides to it. What if you need to tweak the lanes?
Yeah, yes. Or if I'll tell you, the biggest problem with inductive loops is that's got pavement over the top of it. And every so many years, they need to shave off so much of that pavement in order to put another overlay over the top of that. And so when they do that, they just rip the loops up. And so in Pocatello, Idaho, the city wanted to do this massive project that included a lot of what they called system loops on a main corridor. And so they did. They forgot to ask the state, because it was a state run. They asked the state, can we do this? And the state said, yeah, that's great. We'll like to see the data too. And so they said, great, let's do it. 1 month after they spent all the money to put it in, the state also, without telling them, said, oh, by the way, we should have told you we have a paving project going on here. And they completely wiped out all of that technology that was just put in a month earlier. That's the one of the biggest problems. The other problem that you have is you've got people in the roadway working with cars and such going on. So it's a safety issue as well.
So to solve that, the idea was then to go above the roadway, right?
Correct. And the first iteration in going above the roadway was cameras. And cameras seemed to be like the savior of all vehicle detection. I mean, it was going to be so amazing. And you think about it, you think, oh, wow, great, a camera can see everything. But it can't in certain conditions as well. Just like loops have issues, with bicycles, with small motorcycles and mopeds, you have to actually build a very specific loop for the type of vehicle you want to do it. A lot of people think, oh, well, one thing will fit everything. We should have one radar unit that fits everything, one camera unit that would fit everything. And the cameras tried that as well, and they ran into problems. You have to look at what is it that you're trying to detect and then build according to that. Because there's certain, they call them chevron loops and such like that will actually pick up a bicycle much better because they have less ferrous metal to them. And now bicycles have none. And you get bicycles that just cannot be detected at all.
So a camera works with software.
Correct.
To identify vehicles in certain zones?
No. And in fact, if they did, and again, you go back into the late 80s, early 90s is when this was starting to be introduced into the industry. All we were looking at is pixelization. So a camera would look at something, and you just like your LED TV, you have all these little pixels, and it would say how many pixels are being filled up here, and then they would put a zone or an area that says if
wait a minute, I thought you just said no to zones.
No, I know.
Go ahead.
but you would put something there in that lane that says if the pixels change in this lane, that's fine. Well, at first cameras just were, and it wasn't because they had to be, we were in black and white world, but they used black and white cameras. And so what would happen is a gray car or a red car actually, oftentimes in a black and white image would be the same color as the pavement. So there would be no change and you couldn't get detection from it. And so there was a lot of things that they had to work at, but it's that pixelization. So the further back that you go, the smaller that angle of that camera looks at. So those pixels back there are just little teeny tiny things, and you're trying to get detection off of that. It became very difficult as well. And even today, we're still utilizing mostly pixelization in cameras.
Really?
Yeah.
Even though cameras have got higher resolution.
Yep. Well, then the pixelization has become better because of that higher resolution. But utilizing video, it's starting to come into the industry, but video recognition of objects was something we just have not done in the industry. We've stayed pretty basic and pretty solid in the areas that we continue to use.
So the environment poses problems for cameras too.
Yeah, you get into San Diego, where you have sunshine and the same temperature and everything all year round, it doesn't do too bad. But you come into Colorado or into Montana or Utah, where you've got a lot of snow and sleet and maybe freezing rain. The thing is it's optics. At first, cameras had problems with the processing. We didn't have enough processing power to process everything that was going on in the intersection. So the processor slowed everything down. Well, processors now are just amazing. But it's still the visual. It's the eyeballs. If I look into the sun, I can't see what's around me, And so when that sun would come up in the morning, and you have or go down at night, and you have east or west facing cameras, you had to angle them just right. Well, if you angled them down too much, now you're missing detection further out. There were so many issues into that regards, and that's something they just can't. You can't overcome when it comes to vision. If you look at what you can see visually, they can see it visually. If you can't, spiders would actually go up into the camera lenses and build their their webs, and they'd run around on their webs and set off detection all over the place. One time, it was a camera, and a bird was sitting on the edge, and his bird tail was just a big long bird tail was just sitting in front of that camera. It was doing exactly what it was designed to do, and it was detecting. It was not detecting a vehicle, and that's the problem.
So it's great in San Diego until it's sunrise or sunset
or
foggy. Yeah, can't see through fog.
No, can't see through the fog. The other thing is if they had to really increase the amount of lighting at intersections. So the costs, even though that wasn't part of the cost of the intersection, but the cost of the intersection went up because you needed more lighting. If you had a car that came up to an intersection at 2 a.m. because they just left the bar and they forgot to turn their lights on, they're not getting detected because they can't be seen unless you have enough ambient light to shine on those vehicles.
Yeah. So how do we solve for that? What was the next evolution?
The next evolution was something that I, in the industry, had seen variations of throughout the time period of video, and that was the introduction of microwave and radar. And when the early iterations of that were all analog, and radar in its purest form is an analog signal going out and coming back in. It's now been digitized, and so you lock that in. But the frequency shift would be massive. And so you would have, and when a frequency shift happens in the radar, it actually looks and it sees something where it doesn't belong. And so if you had vehicle detection here, but it's seeing it here because of the frequency shift and coming back, and that range shifted, then that vehicle literally isn't where it needed to be, and it may not pick up, or it may pick up in an area you don't want it to pick up. So it was very, very poor detection. It was really good for when you had a bridge. You can't put inductive loops a lot of times on a bridge, and we would use, there's some other little iterations of detection that came in. Magnetometers was another iteration, and it was a little small tube that they would put in the ground, and what it would do is measures the Earth's magnetic field and the change of the Earth's magnetic field of the vehicle going over this very small point. And they were literally about an inch and a half or so in diameter, so you had to have very precise movement places of your cars. That didn't go very well, and also it was analog, and it would also constantly needing repairs and tuning to it. So those were the first iterations. Once radar became a digital platform, it's like the difference of tuning your radio in the 60s and that you had to manually tune in a radio station, and then you drive for an hour or so and it gets out of tune a little bit and you had to tune it back in. That's all analog. That's an analog station. Where now we type in 107.5 and we lock that in, and it's locked in until you can't receive that signal anymore. That's how we digitized radar in that same regard. We gave it a frequency and a hard frequency lock, and now when it goes out and sees that, now things like weather, things like lighting, radar doesn't care. It was the best for those types of conditions. You needed to get an angle at something that you couldn't get that angle with a camera properly, or you couldn't put a loop there because it was a bridge structure or some other, maybe it was specialized pavers that you couldn't put loops into. This all solved those kinds of issues, and it made a huge difference in the industry.
So when people hear about radar in traffic, they think, oh, there's a cop with a radar gun.
Oh, yeah.
Or you're capturing all my personal information
Yeah.
when I go through an intersection or I'm flying down the highway. Is that true?
Video was the biggest scare. People were more scared when video cameras started going up into intersections than radar. I don't think they understand what that radar is, because it doesn't. Video cameras, you saw that it was a video camera. They're going, oh, now you're recording my license plate and you're doing this, and it's all these. Well, they weren't. These were strictly designed for purely detection purposes. They're not utilized. They can't be utilized for law enforcement. They're not calibrated at that level for law enforcement. They're just simply there to detect a vehicle and be able to tell the intersection, I have a vehicle here versus here. Now, there's different iterations. And going back to that example of the loop, saying that there are different loops that you will want depending on whether you want a long zone loop or whether you want a bicycle loop or all those types of things. There's different types of radar technologies that give you different looks to the intersection, whether you're at the stop bar, whether you want to look further back at the intersection, what do you want to use for safety? How do you want to use it for efficiency? Those types of things came into the radar world that never existed in the loop world or the video world, because you couldn't put in enough loops and cameras to do that.
For your average person out there listening or watching this, where do you need to pull up to when you get to an intersection so that you'll be detected?
So you always have a crosswalk, and they're usually very wide. I mean, everybody's seen the Beatles album that has the Yellow Brick Road album, I think it was, and they were walking across the crosswalk. That's
Abbey Road.
Yeah, Abbey Road. Thank you.
You're mixing up Elton John and the Beatles, and that's inexcusable, Dale, but we'll let it slide. Continue.
Awesome. Yeah, so you've got Abbey Road, and you've got the crosswalk. Before the crosswalk, there's this big white line, and that's called the stop bar or limit line. That's the limit in which you are supposed to go and wait until the traffic signal goes. So many people go ahead of that, and sometimes way ahead of that. They're never going to, the zones and the ability to detect you is at that bar. And sometimes they'll put it a little bit further because they know they've got people that'll creep ahead. But that's where you need to be. You don't need to be away from that and worry that you're going to run over a pedestrian because, and stay 10 feet, 20 feet back from that. That's where you need to be detected. If you're a bicyclist and you actually see a physical loop, your hottest spot of that loop is on that saw cut. It's not in the middle. That's the weakest part of the signal. And so you go over there. A motorcycle's the same thing. And so a bicyclist can actually, if they're running a bicycle that's completely undetectable because of the type of composite that they're running on, they can actually put a pretty good sized magnet underneath their bicycle, and it'll actually work as the ability to detect. But again, you need to be over that line. So there's a lot of cool things that people can do if they know the little tricks that happen. If you're on a bicycle, the best thing you can do, if you're not getting detected, go over, push the pedestrian button, and you're going to get a signal.
Yeah. We should say that these different detection systems do capture data, though, and it's really important data.
Oh, that has become one of the most important things we're doing now in the industry. It used to be that the most important thing was to understand where cars were in order to transition that intersection. There's different phases. Think of the moon phases, but there's different phases to an intersection. And some of them are left turn phases, through phases, all of these different things. And they have to all work concisely so that you don't have opposing phases on at the same time, because then you'll have an accident. So what we've done now is that's still important. But what's now more important is all the data that we get out of there. How many vehicles an hour are coming to my intersection? At what direction? Which part of that intersection are more vehicles coming, so that we can make sure that the timing is correct? Because a lot of times these intersections are not just standalone intersections. They're interconnected to multiple intersections, a whole corridor of intersections. So when you mess up one, you mess up the entire corridor. If you've ever driven down a road and you get a red light and then you get to the next signal and it just goes red, you know they have not timed that corridor properly, or something's out of sync.
Or somebody pressed a PED button.
Well, even PED buttons are put into
Are they
that
put into the
timing system, that coordination system. So now one thing that can happen is a lot of times you have preemption systems for like fire departments, and that will take it out of coordination and mess it up for a while, and it gets back into sync. But when we have never been really good about collecting data out of the roadway, what we've done in the past, and again, this is an industry that you think is a very high-tech industry. It's actually a pretty low-tech industry in a lot of ways. We would send college students or hire people to go out with clipboards, and they would literally like punch buttons and fall asleep and go, oh no. And then they'd hit it about 10, 15 times because they didn't know how long they dozed off. And it was horrible data. Now all this data can now come out of the detection, and now they can utilize that data to make those corridors and that in sync so much better than they ever could. That's what's coming. Eventually, we're going to tie that into vehicles and hold the whole vehicle to infrastructure. That's a whole nother episode there for you.
Yeah, and that's been talked about forever, right? Mm-hmm. Autonomous vehicles and vehicle to infrastructure detection and communication, and everything just smooths. It runs smoothly. Nobody ever has to stop. But my question would be, where are we going with traffic detection in the future?
Oh, wow.
You don't have to go in depth, but
there is always going to be a need for some type of physical detection in the roadways. I truly believe that. And as a company that produces that type of detection, I hope there is, because that gives us a longevity to what we're doing. But there will be a time. The biggest problem now is communication and the amount of bandwidth that's required in order to pull this off. The other thing is, in the communication side, is getting all of the manufacturers of all the vehicles, all of the infrastructure, everything, utilizing the same communication capabilities and protocols. That will take maybe an act of God to actually figure out how we're going to do that, because we've never been good at that in this industry. So we're several years down the road before you start seeing the vehicle to infrastructure. The autonomous vehicles are here.
Yeah.
We have autonomous taxis already on the road. We have a lot of things that are in that realm already, but they're not talking to the infrastructure as we want it to be. And that will come one day. I don't know when. I always thought it was good a lot sooner than it is, and I now think it's a lot later than we think. So
I just hope that when I'm a really old man, I can't drive anymore. My kids have taken away my keys. It won't matter, because the car will just take me wherever I need to go.
An interesting thing on that point, too, is I was in a conference, and at one point they thought that autonomous vehicles and everything else would actually reduce the number of vehicles on the road. And then they realized that if you build little pod cars, that'll actually increase it, because mom's going to have 4 or 5 little pods, and one kid needs to go to soccer, one kid needs to go to piano class, and she's going to stick them in these pods, and they're just going to go there. So now they had to rethink. They're rethinking everything they thought about what is needed for that kind of infrastructure, because we're not built right now for that kind of infrastructure.
Wow. You've been everywhere. I mean, you are the most well-traveled person I know. What does traffic detection look like in different places in the world?
It's some interesting aspects of traffic. In the 80s, I was in England, and England had mostly roundabouts. And I really came to love roundabouts. You have to really trust yourself and all the other drivers when you get into a roundabout, especially a busy one. I went back at about 1999, and they had signalized a lot of their roundabouts. And I'm going, wow, this is really different. The capacity of a roadway is so important to be able to make intersections flow properly. And so I think every country is looking at different ways. I mean, I've been in China, where it is literally a free-for-all. And you look at this and you're just going, there is no way. And I've actually captured it in video to try and show someone that, could you imagine this here in the United States? And there's no way. There'd be accidents left and right. And yet you don't see accidents. So whatever they're doing is fine. A lot of times we overthink our industry, and we keep thinking we've got to solve this problem, this problem, this problem. But what we're doing is a lot of times putting more layers of problems on top of that. We found that in the rail industry. You had a stop sign. Well, people didn't stop at the stop sign at the railroad track. So then we put lights. Well, people didn't stop at the lights. So then we put arms down. Well, some people go around those arms. So now we put 4 arms down. So we keep doing different things to try and keep people from doing things they shouldn't do. But in some ways, we create other problems. Like what would happen if we put 4 arms down? We trap a car in the middle of that. Well, we got to find a way out of that now that we didn't have to do before. So we need to keep things simple. I think radar is one of the most simplistic, raw detection capabilities that gives you so much information that you can do a lot of things with that really simple detection. It's not complex. Video is fairly complex. Loops can be very complex as well. But radar really does make it more simple in a lot of ways.
So why are you so passionate about this? Why do you know everything about transportation?
I was with a customer. I've been doing this for 30 years. And he told me, he goes, I have never seen anybody been in this industry this long that's this passionate about what you do and who you work for and that. And I go, it's just me. I just love it. I love to be able to take and look at a problem, or to be able to show someone a solution that no one has ever shown them before, or look at something just as slightly different than everyone else has looked at it. And the light bulb goes off and they go, yes, that solves this problem for me. And when that can happen, when you work for a company or you're part of an industry that makes it a difference, it is just, you get real passionate. Now, I get very passionate on the other end too. My mayor and city council members hear from me a lot when it doesn't work, and it's easily solved what's going on here. And so I don't know what actually drives the passion as much as I just truly love this industry and embrace the ability to change people's lives. And it really does make a difference, whether it's getting to a doctor's appointment, or whether it's getting to a child's musical at a school. And those minutes of delay become so frustrating. And if you're just a little bit late and that child just finished his piano recital because you as grandma or grandpa, you just made it that much late, and you look back at your journey and you're going, oh, if I only didn't hit that red light at that time. To people, that's where it makes a difference, because they don't understand what goes into that, but they know it wasn't right. It didn't feel like it flowed in a certain way, and be able to actually take and remove that away from that equation and get grandma to that recital on time, or get somebody to a doctor's appointment on time, whatever it may be, that to me is thrilling.
And I don't know if I've ever met a person, maybe you know somebody, because you've been in this industry forever, who loves red lights, sitting at a red light.
Oh, no. One radar that is developed actually looks back 900 feet back from a roadway, looks at all the vehicles approaching, looks at areas where it would normally go to yellow, and then you got to look and go, oh my goodness, do I stop or do I go? And it actually looks and says, oh, let's just go ahead and hold that green a little bit longer and give you more green. And when I explain that there are technologies out there to just the common person, they go, why isn't that everywhere? That is the worst feeling ever, is to get that yellow and be so close that you've got to put the brakes on really hard, or you just got to go, okay, I'm going to go for it.
Gun it, yeah.
And hope nobody hits me on the side as well. That is what makes it so important to us as an industry, to do those right things and make it right.
Yeah, and that's called the dilemma zone.
It is.
And because it's a real dilemma for the driver, do I slam on the brakes or do I gun it? And with that system, that is out the window. You don't have that sort of timing where it's that tight that you need to do that, right?
Yeah, correct. And when you tell people we're giving you extra green time, they go, thank you, I love green. I love the green light. And no one likes the yellow or the red. Yellow means go faster. Red means stop if you can.
Yeah. Everybody loves that green wave. Even if you're not a Green Bay Packers fan.
Yeah.
Right?
And around the world, I've seen areas where they do it better and worse. And then you've got places like Amsterdam where you throw in like 1 million bicycles into the whole mix. That's a whole different transportation system. But they've worked that through, and they've actually built their infrastructure based on that. That's one of the big things. You have to have the infrastructure in place. You have to have the technology that allows you to do what you need to do. And then you have to implement it. And it's not a cheap industry to implement stuff into.
How many times have you been to Amsterdam, Dale?
I've been to Amsterdam 4, 5, 6 times. I think.
Yeah.
I don't know.
I thought it was going to be in the 20s. Who
No,
knows,
not quite that many.
Yeah.
It's a fun place to go to, and actually for traffic studies and such, it's really really fascinating place.
Okay. Well, let's book a trip. Let's go.
That's right.
Sounds fun. We'll get a bike. Anything else you want to talk about that we haven't discussed? I mean, there's so much that we can go in depth, but this is an overview.
As people who use the system, a lot of times they don't realize even what a pedestrian button is. I wonder sometimes what we should teach kids, like in driver's ed. That should be something that we teach in driver's ed too. What does that pedestrian button really do? And you just simply hit it once, and it just simply sends the signal saying there's somebody waiting. The more times you hit it, it doesn't make any difference. And you'll see people just hit it, multiple times. And it doesn't change anything. It just puts one call in no matter what and says, and you wait. Then you don't get it early or anything. It just says when that goes green in that direction, also pull up the pedestrian. But because the pedestrian's a phase that you also don't want any kind of side traffic or anything else to conflict with it. And so and then you have so much time, about 4 seconds per lane, to walk across the lane, the roadway, and then it says you shouldn't step off the crosswalk anymore.
So if we've accomplished no other good today,
I hope people have learned that.
Press the ped button and pull up to the stop bar.
And pull up to the stop bar. Yes,
make all the difference.
Correct.
Thanks, Dale.
You bet.
Appreciate you being here. Appreciate you being here for Pulse, our podcast from Wavetronix. We'll see you on the next episode.